In here I have samples of 3 different objects. You have object A, B, and object C. Each one of these have 3 faces that are seen, and let's consider this side the front side. Object A, so this would be seen from the right side angle, and then this one left side angle. This is the same object here and there. Object B is displaying the right side view, and then right side from a bottom angle here. And then object C here has a couple of slanted planes here and there, and we can see the right side upper angle here and the left side upper isometric angle. All of these 3 objects have the same front view. We have a rectangular shape, even though this is angled. If you're standing in front of this looking at that direction, is only going to appear as a square. Okay, so we will not see the angle from the front view. See? So I want to show you how each one of these would look if I was to only draw the top view and the right side view. Starting with object A, here is our front view. So once I project from that view to the adjacent views, I generate the top view. Now let's look at this side right here, which is this plane, is going to be visible from the top view. So this line right here is visible, and then this plane continues under this section, so that's why on this area it converts to a hidden line. And then we project those lines from the top view. Okay, we establish a matter line, and then from there all those projections go down, and you see where they kind of meet here, and that will allow us to form the next view. Now let's say I don't have the 3D anymore and I only have these 2 views, and I need to project to the right side view. So for teaching purposes, I color code, and I need to identify which of these lines is going to be what plane. Now because these planes are visible in the front view, I am going to look for horizontal lines or even angled lines that take up the same width as that plane. So let's start with the red plane. It has a width of 2, so I'm going to look for a line that has a width of 2. Now I have this one and I have that one. So I'm not completely sure which is which. I'm going to just leave those and kind of think about it for a little bit. But I do know that this line continues with a hidden line here. That might be an indication to where this line here is not the red surface. Let's continue on. Let's look at this blue one. Blue one takes up 4 width units, and so I see that the only line that actually has 4 units is that one, so I will take that as being the blue plane. And then I have the yellow. Now I'm looking for a line that goes all the way across the object. Of course I have the back, but the back plane cannot be seen from the front view, therefore I eliminate the very back line. And then I have this line here. First, it starts as a visible line and then converts into a hidden line. That makes sense since yellow is under blue, and then as you can see, blue extrudes out or is closer in depth to me than that yellow. Then it makes sense for that yellow to convert into a hidden line. So now we know that this and this plane, that line, represents our yellow surface. And because we identified that as yellow, then we know that this one is our red plane. So now that I have my 3 lines here, I can kind of follow the information now. From the top view, we project from that plane to our miter line and then down to the right side view. And then we will project the height of that plane onto here, which would make this line from there to there be the line that is representing our blue plane. Okay, the red plane has the same height and the same position for this blue plane here, so it's going to be at this same height. I can never find red here because it doesn't line up with the height information that I have for the object. Red has been identified to be here in the top view. I follow that line. This is the projection here. So I know that red will be here and here. That's the height of the plane. From there to there is the height from the plane. And then it projects from the top view. So its depth is going to be 2 units from blue. That red is going to be hidden because from the right side view, which is right here looking into the object here, this line being the full depth of the object from one end to the other, make this plane hidden there. So this becomes a hidden line. And to locate yellow from this plane, I project to the right side view. Yellow has only this height here. I follow the projection from here and then from there, and then my yellow line is there. So now that I have placed those, I see that nothing else is going on as to any more features in the object. And so I look to see what each one of the planes is. Like this plane that I did not color code, let's say I color that orange. This will become our orange plane. So where would orange be in the right side view? Well, as at the very top of the object. And over here it projects the full depth. So I project from the top of the plane all the way to the back. We draw a visible line from here to the yellow, okay? And from the yellow all the way back here and there. And now we have to figure out what happened to the red one. So the red line would have a hidden line from here to there, and that would finish the right side view. So without looking at the isometric, I can come up with the right side view of the object because the other two views have enough information to give me that multi-view. After that, I clean my drawing and my 3 views look like this. With this object, I want to start a little differently. Now let's say I was provided the top and the right side view like this, and I know this is the top and right side view because they're not lined up vertically or horizontally. They are diagonally, so that means that a view is missing here, and that would be the front view. And so I need to figure out what that front view looks like. Now let's say I was to project from this view to the other so that I can make sure that I can locate where each one of my planes are. So from the back of the object, I am going to project horizontally all the way up to the back of the object on the right side view, and then bring that line there. Now from there, I can draw my miter line. That just establishes the point, and my miter line is 45 degrees, so I'm going to go diagonally. That miter line can be as long as I want it to be, but it's not necessary. So now I can transfer all of these dimensions to the miter line and down, and you see how each one of these corners match up with a feature on the other view. Okay. So now I can safely say, if I was to color code these, I could say this hidden line here, and look at where it projects from here down, and this plane are both going to be the same plane. Then I have this one that matches up with this line, and that is going to be green. And then this one matches up with this line, and that is going to be yellow. Okay, so those 3 planes there. Now I can project from one view to the other. Okay, I'm going to start with my yellow. So I project from here to where that yellow starts on the right side view, and then project here again to where that starts. Okay, so that is the full width of yellow. Then height of yellow will be here, and then height of yellow will be here. So yellow has a width of 2 and it has a height of 2. And because the front view displays height and width, it will show up as a square. All right, let's move to green. It's in the same height as yellow, but it has a width of 4. And notice that it starts adjacent or next to yellow. It has a width of 4, height of 2, width of 4. And then the next plane is the orange. And then draw that plane here that has a width of the full width of the object, which is 6, and height of 2 at this bottom location. And that's how I would generate the front view. Now if I was to bring back my object, you can see all 3 views and clean my drawing. This would be the end result. And now I just want to show you the end result for the third object. Let me show you the projection lines for that. And again, without them. And now side by side, so that you can see that all 3 of these shapes have the same front view.